Hey everyone, so today I'm going to be teaching you how to create LoRa's for Hunyuan Video. So LoRa's, if you don't know, you can basically train the model to understand things more specifically that it may not have understood without the LoRa. You can train it on specific people, you can train on specific motion, you can train it on specific styles, like black and white or anime or certain film styles. Um, so it's a pretty useful tool, and we'll dive right into it. So I have this dumb little data set of just stick figure drawings. I don't know how well the model's gonna understand these, but um, at the very least, I'll be able to show you how to set up the training software and run it, and you can use your own data sources to uh, hopefully get better results than this is gonna give me. Okay, so first thing we need to do is we need to pre-process all of these images. So we're gonna use something called, it's a TD Russell Pipe-Diffusion, or Diffusion-Pipe, sorry. So this is the GitHub repository for it, and he gives us some advice on how to handle training. So here, if we go down to the Hunyuan Video, um, so you can use the images to train this. You don't have to use video, but images sometimes produce less movement, and you sometimes get more unnatural movement. I have trained 1024 by 1024 images, and you get pretty good likeness when using character LoRa's, but like I said, the movement isn't very good. Video was much better. The only downside is on under 24 to keep it under 24 gigabytes, so to fit it on like an RTX 4090 or an RTX 3090. You can only use 512 by 512 width and height and 33 frames. So that's like a little over, it's like one in a little bit seconds on a 24 frame per second video. So I'm going to show you how to pre-process your images to get it to fit within this 512 by 512 by 33 frames size, and then we'll go through how to set up the training. So first thing is we need to set. I'm going to use ComfyUI for this. I'm sure there's other softwares that probably are better, but this is what I'm going to use. So there are a couple nodes custom nodes we need that I already installed to follow along with this. Oh, I didn't install the ComfyUI manager, so let me just do that real quick in the background here. All right, sorry about that. So there are two custom nodes that I've already installed in the background. I installed them command line, but you can always use the ComfyUI manager to install these. So one is the video helper suite. When dealing with videos, you almost always need this. The other one is ComfyUI Essentials. Comfy Essentials. Yep, there it is. ComfyUI Essentials. So this gives us a image cropping node that I find really helpful. I think it's the best one for this application. Okay, so let's set up our ComfyUI workflow. Load video. All right, we want the upload node, the load video upload node. And remember how I mentioned before, it can only be 33 frames long, so we're gonna put a frame load cap of 33 on our video. Next, let's take a look at the videos and see how large they are. So the dimensions in my video are 1920 by 1080, and I want to make sure that the video fits within that 512 by 512 size. So I want to resize the video. I want basically half size. So I'm gonna do an upscale image by, and I'm gonna scale it by 0.5. So basically dividing both of the dimensions by 2. And then for the upscale method, I always use Lanzio. So that typically gives the nearest to original image. Okay, so that gives us a image that's like 960 by like 540, something like that. So now I need to crop the image. So I prefer this ComfyUI Essentials image crop over the native image crop. Really just because it gives you this position field. And then after it's cropped, we just want to, and then we need to set the height and width. So I said 512 by 512. And right now, so that's going to start in the top left and crop 512 by 512 out of that. But we could also tell it to start in the top right and crop 512 by 512, or the bottom crop 512 by 512. So yeah, that's why I prefer this node. And then we're going to combine the video and make sure we keep that 24 frame rate and change it to save it as an MP4. So let's upload one of our videos. Okay, and now I want to grab a specific part of this video. So I don't want that that mouth to be in there because it adds color, and I don't want color. So I'm gonna just grab the first 33 frames, and then we're gonna try to grab that part where she blinks before the mouth shows up. So she's in the center. So I'm gonna put the position as bottom center, and then I'm not gonna do any offset, and we'll start it up. So there's movement at the beginning. I want to capture that, and then I also want to capture where she blinks and then smiles, but before we see any of the color. Okay, so we have our first video here. You can see it's square, 512 by 512. You can just right click on that and hit save. Okay, and then now to try to capture that specific part of the video, we skip frames. So these videos are all 5 seconds and I believe 30 frames per second. So it's 150 frames long. So I can estimate maybe 3/4 of the way through the video that blink starts. So let's try 110. Remember that if you go, since there's 150 frames, the max skip first frames you could have is 126, because after that, 116. After that, you're going to run into the end of the video, and you're going to end up with less than 33 frames. In fact, a good thing to do here is there is a show any node. I think it's in one of KJ's node packs. You can Google it. It'll be pretty easy to find, but that's you can print how many frames you're getting. So let's give it a let's give this a shot. I actually think it's going to start around 80. I think if I start at 110, I'm going to get that end of the video with the color in it. All right, so it's pretty close. I want just a little bit more of that mouth and arm movement. So let's try like 85 frames. Okay, I'm good with that. It just shows the tiniest hint of color, but I don't think that's gonna mess with our LoRa too much. So I prefer getting more of the movement in this case. So I'm gonna go through and process the rest of my videos that are like this, and I'll speed through that, and then I'll come back once the data set is complete, and we'll go through and install Diffusion-Pipe Pipe-Diffusion, and then we will train the LoRa. Okay, so one last thing I didn't mention is how many of these videos should you have? There's all different recommendations. Hunyuan LoRa training is still pretty new, so I've heard some people say they got good results with 5 to 10 videos. I've heard some people say it took them 20 videos. My recommendation would be, grab 20 videos that are 512 by 512 by 33 and choose your best, 10 to 15 of them. I've trained on about 14 and I got pretty good results. Okay, so the next thing we need to do is we need to create captions for all of our videos. So I've created a Visual Studio Code folder here with all of my videos. And what I'm going to do is I'm going to rename all of these. So I'm going to use ChatGPT to create us some Python scripts. So I want to rename all .mp4 files in my current directory with the naming convention. I'm going to do so this is just like going to be kind of stick, but in weird writing. This is how you caption for Hunyuan. We'll go through that in a minute. Underscore x.mp4, where the x is the current iteration of the loop. Write me a Python script to make sure I don't have to put in a function variable, just use the current directory. So this is I just used ChatGPT to write me the Python script to rename these. We'll just call it rename.py, and we'll run this, and it should take all of these files that I saved and rename them with this stick underscore iteration naming convention. All right, so there you go. So we have 10 videos here. The next thing we need to do is create captions for all these. So again, I'm going to use ChatGPT to create just to create blank text files for all of these. All right. Now use the current directory and look for .mp4 and create a .txt file for every .mp4 file. call name the .txt the same thing as the .mp4 file. Now write a Python script using okay, this looks good at a glance. All right, so then, oh, actually, there's one more thing we need to add into that script. Use the same prompt as above, but in each text file, I want only the text stick in this weird writing. So let's create this Python file, then I'll explain. Actually, I'll just do it now because you're gonna need to know what you want to name this LoRA. So LoRA's use something called the trigger word. The trigger word is a nonsensical word that the model won't already understand. So if you use something like the word stick in the LoRA caption, the model already knows what a stick is. So it'll kind of do weird things like try to merge your character and or your motion and sticks, or it'll, you know, sometimes it'll use your LoRA, sometimes it'll use regular what it understands a stick to be. So we use this like nonsensical number letter writing to caption the videos so that it basically learns a new word. It learns that this word is associated with the videos that we input. Okay, so now we updated the prompt to write a stick inside of it, or inside each text file. So I'm going to copy that. If you're not confident with Python, you could always create all these files manually. I think it's pretty cool that we can use ChatGPT to do something like this. So I'm showing you guys how I would do it. All right, so now we have all these text files. Very important that the names match, right? So all of the .mp4 files have a matching text file. So if you've trained LoRa's in other, for Flux or for Stable Diffusion XL or 1.5 or something like that, you know that sometimes we'll add more description behind this. You can do that with Hunyuan, and some people have reported better results using like an LLM like Apollo, which can caption videos. I'm not going to do that today. I may make a video in the future about how to use Apollo to automate captioning. But I've used just one word trigger word captions before, and the LoRa's come out great. So I think that maybe if you were going for 100% optimization, it would be necessary, but I think this gets us like 95% of the way there, which is generally good enough. Okay, so now we have our data set, and it is time to install Pipe-Diffusion, or Diffusion-Pipe. I always mix them up. All right. First thing we're going to do is deploy a pod. I mentioned earlier that this needs at least 24 gigabytes of VRAM to train videos, and that is for the minimum 512 by 512 videos. So 4090 is significantly faster than 3090, and training videos does take a long time. So I would recommend going with at least the 4090. Okay, size requirements. Because we're gonna install ComfyUI on this also, I would recommend going like 50 on the container disk and 200 on the volume disk. You can play around with these if you find out it's not necessary to have this much space. You can always lower it, but storage is pretty cheap compared to the GPU. You don't want to find out halfway through your training that you don't have enough disk space to hold all of your epochs. Okay, and then let's just expose port 3000 as well. Let's actually do 3000 and 2000. I'll explain why we have these exposed later in the video. Alright, so now let's deploy. So I am making this little amendment to the video just as a warning. I got pretty far along in the process, and I had my pod run out of RAM, which causes it to crash and you can't recover from it. So when you are spinning up your pod, make sure you get one with, you know, I would say 50 or more 50 or more RAM. Unfortunately, there's no way to specify how much RAM you need. You just kind of got to get lucky. So I'm just going to spin up pods until one has around 50 or more RAM. Okay, so we got one with 46 gigabytes of RAM. I think that's going to be enough. Okay, so we have our pod up here. All right, so first things first, let's just get our ComfyUI environment set up. So let's clone ComfyUI in. And you'll see why we're doing this right up front in a little bit. Let's create the virtual environment for ComfyUI. And activate that virtual environment. Here, I'll just show you real quick. So we have our VENV here. So there's VENV/bin/activate. Okay, so this VENV pops up at the front, and now let's, we're looking for this requirements.txt, so we're just going to install the requirements for ComfyUI. Okay, so now that we have ComfyUI installed, let's just install the ComfyUI manager as well. It's just easy. You know, some people don't like the manager because it can throw some weird inconsistencies in your environment, but it's convenient, especially for something like this where there's a few nodes we might need later on after we've installed or after we've created our LoRAs. All right, so I cloned ComfyUI manager into the custom nodes, and then I'm gonna dive into that folder so that I can install the requirements.txt. Where is it? Requirements.txt. All right, so we have ComfyUI installed. You'll see in a minute why we installed ComfyUI first and didn't just install Diffusion-Pipe right away. So first thing we're going to do is we're going to clone Diffusion-Pipe. So this is the, if you just Google TD Russell Diffusion-Pipe, you'll find this GitHub page. And I'll also link it in the description, obviously. So let's copy that command and just clone it in your base workspace directory. Okay, that's it. And then let's go into that. We're going to create a virtual environment, just like we typically do. And we can see the virtual environment pop up. All right. So in his in TD Russell's description, he recommends using Conda, but with RunPod, Conda is not as necessary because we're not, you know, it makes more sense to use Conda on a local machine where you might set up, you know, 15. You might have 15 different softwares that use Python, and you want to use different drivers and things like that for each environment. Here, we're going to use the same drivers for both for ComfyUI and for Diffusion-Pipe. So I just went with Pip or with a virtual environment, Python virtual environment. All right, so he recommends create the environment, then he recommends to install NVCC, which I actually think we already have. We can check it. We can check it with this command nvcc-version. And there you go, we already have it installed, so no need to do that step. And then we just need to install the dependencies. So pip install our requirements like we've done for ComfyUI. Oh, okay, so we had an error, no module named torch. So that means we need PyTorch installed. So install PyTorch. Okay, we want the pip version on Linux, so it recommends this. And we want it on CUDA 12.4. So it recommends this command. Oh, and you know what? There is one more thing here that's actually, if you've watched any of my other videos, it's another issue when you try to install Sage Attention. We need to upgrade the wheel package. Okay. So so that installed Torch, and then let's go back and install requirements.txt. All right, and then we do just have a Torch incompatibility here, so let's uninstall Torch audio. And then we're going to install the compatible version. All right, now resolved our dependency issue. Okay, so now we'll get into Diffusion-Pipe. So really cool. The data sets are very well documented the files to run Diffusion-Pipe are very well documented. So let's just start from the top here. So our output path directory, this is where it's going to put the this is where Diffusion-Pipe is going to put the LoRa's after each training cycle. This is where it's going to put the LoRa's. So this is why I had us install ComfyUI right off the bat. We're going to change this output directory to the ComfyUI directory. That way, we don't have to move the files once they're created. We can just start training right away. So, start testing right away. So, ComfyUI, the LoRa's folder is models LoRa's. If you want, you can create a folder here, call it like Hunyuan or something, but I'm just gonna use this path. So if you right click on the LoRa's folder, you can hit copy path, and then we'll just paste that into our output directory here. Make sure you have a slash in front of workspace, or else it'll try to use a relative path, which isn't what we want. We want it to use the actual path. Okay, and then our dataset config file, so that's right here. So it's examples and dataset. This is going to be the dataset configuration that Diffusion-Pipe uses to train the LoRa. I'll open it up, but we'll go through this once we're done with the Hunyuan Video configuration. Okay, so I use what he recommends here. Usually set this to a really high value because you can stop it at any point and then restart from a checkpoint, which is a really useful feature. Batch size, just use one unless you have multiple GPUs. This isn't necessary to change. Same thing with this one. Gradient steps, I just left it as 4. Same, all of these kind of just left alone. The only one I can really see playing with is this warm up steps. Sometimes the first 500 steps of training aren't really relevant because the model is going to be undertrained and you know that. But 100 is a good starting place. So eval settings. Eval every and epochs. I usually leave this at 1. Just make sure you give yourself enough space in the run pod, and you don't want to have you don't want to evaluate like every 5 and you miss the best one. So these are all evaluation settings. They're not they don't actually affect how many LoRa's are being trained. They just are affecting how often it's being evaluated. Well, I'll show you how it evaluates the LoRa's later on once we're doing the training. Okay, so miscellaneous settings. So in his note, he says probably want this to set this higher if you have a smaller data set and you don't want to end up with a ton of saved models, but we should have plenty. I mean, you can see we have only 4% volume used. We're gonna have to install the Hunyuan video models, but they're only gonna take up maybe a third of this, and then we have all that extra space for LoRa's. So I'm gonna set this to 1. And then checkpoint so you can either checkpoint every certain amount of epochs, or you can checkpoint every certain amount of minutes. I actually like doing this after, I've done it both ways. It really doesn't matter a whole lot, but it's probably it's probably best to do it every some odd minutes because the checkpoints are pretty large. And maybe set this to like 30 minutes. So you can come back every 30 minutes, check on it, evaluate your training, and then restart from that checkpoint after you're done evaluating. Activation checkpoint you can keep as true. The rest of these you can keep as true. The only one to note here is this video clip mode, single middle. It shouldn't matter for us because we use 33 frames, which is the whole like that's how many frames we're going to train on. But if you used like 64 frames or like 50 frames or something, it would start from the middle and go to the end of the or it would cut off equal amounts of frames on the left and right or beginning and end of the video. Okay, so now we get into our model. So this is the most important thing here is that you want to use the FP8 model. If you use the BF16 model, you're gonna run out of space. So make sure you use the FP8, and we're going to download all of these files from a shell script on my Patreon. I'll also link where you can find these files to download them manually if you want to, but using the shell scripts just does it for you, and I don't think you guys want to see me go search out models and install them manually for the whole video. So I'll show you where to find that shell script, how to run it, and then we'll go back to putting the right paths in here. Okay, so let's go to my Patreon. The Patreon will be in the description, by the way. All right, Hunyuan Video model weights, and let's download this installer. And like I mentioned in other videos, check my file. You don't want to just download it and run any shell script because it can do some kind of nasty stuff on your. I mean, if you're using RunPod, it's not your local machine, but if you're following along and using your local machine, always check that you're always check the shell scripts to make sure you're not downloading something nefarious. All right, so this is going to download our models. It's going to download our clips, and it's going to download our VAE. So let's just go into our. So I put this in the ComfyUI directory, by the way. So we need to navigate to the ComfyUI directory. You can see it right there, ComfyUI, Hunyuan model installer. And then we just need to do bash Hunyuan model installer.sh. And it should download for us. So it's downloading ARIA2C, which allows us to download models faster. And now it's downloading models. It's going to take a minute, so I'll see you when it's done. Okay, so model weights are downloaded. If we look in here real quick, I'll just show you. So we have our clips in here, our Llama text encoder. We have our diffusion models, our Hunyuan video models. So we have everything that we need to train this LoRA downloaded now. All right, so let's navigate back to our Diffusion-Pipe. Oh, sorry, I navigated back too far. CD workspace. let's navigate back to our Diffusion-Pipe folder. Okay, and then let's go look at our Hunyuan Video .toml again. So transformer path, so this is our model weights path. You can see the Hunyuan FP8 model here. So let's go to our ComfyUI folder and see where we saved all these things. So we have models, so we saved the FP8 Hunyuan model in diffusion models, and then here's the FP8 path. Okay, so let's copy that path. And paste it over this. There you go. And make sure again that you have this slash in front of the workspace. We don't want the relative path, we want the actual path. Okay, then we need our VAE. So that's in the VAE folder and model in the ComfyUI models folder. And we can see it right there. So let's copy that path. Again, make sure that slash is in front. Otherwise it won't find it. The large language model path, so our llama path is in the LLM folder in ComfyUI models. And so this one, you want the whole file. You want this whole the whole folder. You want this whole folder. So let's copy the path for that folder. Make sure you get that slash in front. And then in our clip folder, same thing here. We want the whole clip vit large patch folder. Copy that, making sure that slash is in front. Okay, so now we have all of our models. So if you are following along and you are on Linux or you're not using RunPod, I'll link where you can find all of these files. And you can just download them yourself and then put them into the make sure the paths are lining up correctly, like I did here. Okay, so we have all of our model paths. There's only one other thing we really need to change on here, and it is this learning rate. Okay, so so a lot of people, so this is just the default that's put in by TD Russell. A lot of people, because video models are long, are using 1e to the minus 4. So 2e to the minus 5 is essentially 1/5 of 1e to the minus 4. So it's going to train 5 times slower. So you get more precision with 2e to the minus 5, but at the cost of going a lot slower, and video training is already very slow. So I would recommend either 1e to the minus 4 have gotten good results, or you could do 5e to the minus 5 if you want to be more precise and you're okay with, waiting. It might take a day to train at 5e to the minus 5 to get good results. So I'm actually so I would recommend this 1e to the minus 4. I'm gonna go 2e to the minus 4 because I want to just train quickly and give you guys just give you guys a demonstration of how to use the LoRA. And I don't want to train it for a whole day because I'm not going to use this stick figure LoRA in practice. Okay, so so that is all of our configuration for the training setup. Now we have to configure our data set. All right, so if we go back to Diffusion-Pipe, workspace, Diffusion-Pipe, go to examples, open that dataset.toml, and let's take a look here. So resolution, so you can try other resolutions. I'm going to be using 512 here, but I mean, you can try 768, you can try 1024, but you probably need more VRAM. You probably need more than 24 GB of VRAM to train video. If you're just going to be training pictures, you know, you could try whatever you want. You could try up to 1024. I've trained on 1024. When we talk about this 1024 or 768, this is the length of the longest side of the video. All right, so let's knock this down to 512 because our images are 512 by 512. You don't really need to worry about any of these frame buckets. Okay, so this one, we are just looking at 33 frames. So let's just only use 33. And then number of repeats, you can keep it at 10. And the path here. So this is the path to our data set. We haven't imported our data set yet, so let's do that now. All right, so I'm just gonna make a folder called inputs inside the Diffusion-Pipe folder. And then I'm going to grab all of my MP4s and text files and then just drag them in here. All right. So let me just give a quick test of one of these, make sure it is a video. All right. So again, I have no clue how these are gonna turn out with Hunyuan Video, but Hunyuan Video is pretty smart, so I'm hoping we get something resembling a stick figure at the end. All right, so our path here is the folder for all of these. So it's this inputs folder. So I'm gonna right click and copy the path. And again, make sure you don't forget that slash at the front. And then that is it. That we are ready to train. Okay, so let's go back to the GitHub repository here. And we have this command here from TD Russell to train. And we're going to copy that into our terminal. If you wanted to change your, if you wanted to not modify the example and you wanted to create your own files here, you can, put them anywhere you want, and you just need to change this path to be the path to your toml file. Okay, so in the case here, I didn't change the path. I just modified the example, and let's run it. So you just need to copy this in here. Make sure Diffusion-Pipe is your root directory, and let's go and see if it works. All right, so here's the spot where we can tell whether we did it right. We're caching 10 latents. Those latents corresponds to our 10 videos that we're using, right? So this should be, if you have 14, it should be 14. If you have 20, it should be 20. Oh, okay, so this is a good error, actually. This is something that I learned. So it needs, the file path needs to be an empty folder. So because I had, because this put LoRa's here file was here, it did not want to it didn't want to use that as a training directory. So I deleted that file. You could alternatively create a new folder and change your configuration output directory. And it's pretty cool because we cached these, it went through it much faster. All right, and so we got our first step here. So it's about 30 seconds per sample, and we need about 2,000 samples. So if we do the math, uh, 2,000 samples times half a minute. Yeah, so it's about 16 hours to get to 2,000 samples. You can maybe after 10 or 12 hours, that's probably around the time when you'll find your best epoch. You might find around like 4 or 5 hours you find it. If you had a really good data set, it might only take 4 or 5 hours. But I'll be back in a few hours. I'll show you how to look at your how your training's going, and then after that, I'll show you how to test the LoRa's in Hunyuan and see how they came out. So yeah, I'll be back in a few hours, and I'll see you then. Okay, so we're back here. I've had this training for a few hours now. We have about 18 LoRa's saved. So I am going to show you how to test these LoRa's now. So the creator of Diffusion-Pipe, T.D. Russell, provided a toolkit for us to be able to look at how the quality of our LoRa's, and it's using this library called Tensorboard. So we want to look at the Tensorboard for Diffusion-Pipe. So if you look over here, this is the ComfyUI LoRa's folder that I had open, models, LoRa's, and then this is the directory that I've been training in. You can see all of my epochs here. This is the file that we're looking at. This is the Tensorboard file, and the way that we call that file, we right click on copy path on the folder that we've been training in, and then we say Tensorboard --log dir, and then we make sure there's a slash in front, and we paste the path to that folder, and then we want to do host on 0.0.0.0.0. That's just the default, like when we want to go to connect through here. That's 0.0.0.0, and then it's port 2000 is the one that we're gonna run it on. Oh, sorry, I missed the --port space 2000. Okay, so now Tensorboard is running on that at that location. So let's go check out what Tensorboard shows us. All right, so we get this graph here. And it's basically showing us the loss that we are experiencing, or the loss that we're training, or the loss for each epoch that we've trained. So generally, you want to try to test around these like local minimums. So usually, like, because this is kind of continuously going down, that means that the model is still learning. But when you get to around this epoch 11 or 12, where it's almost like a local minimum, and then maybe 14 and 18, that signifies that those might be good epochs to check out when we go to test our epochs. So I am going to kill our training and we're going to take a look at these epochs in an actual Hunyuan video workflow and see what our results are. Alright, so let's kill this Tensorboard. Let's stop the training. And then this is where you're going to see it pay off that we use the models LoRa's directory for ComfyUI to, really all of the, we use ComfyUI for all of our directories. We used it for our models and for our LoRa's. So we're going to start up ComfyUI, main.py, -- listen, -- port 3000. All right, so we only have ComfyUI Manager installed. That's not a big deal. We're just gonna have to install the video helper suite and the Hunyuan Video Wrapper through ComfyUI Manager. So let's go back to our pod and connect to port 3000. All right, and then like I mentioned, we need to install Hunyuan Video. And then let's also install the video helper suite. And then we'll restart ComfyUI to have those nodes take effect. And then refresh to see those nodes. So I'm going to just double check that I killed the training here. Yep. Let's get this Tensorboard going again because I want to be able to look at which epochs are optimal for us. Okay, so let's build our workflow. So first thing, I'm just going to look up Hunyuan. Let's start with the sampler. This is kind of like the middle of kind of like the meat of the workflow. We're going to load our model off of here. We want to load our torch compile arguments. We'll just leave the default there for now. We want our block swap arguments, although we probably don't need these unless you're running on, if you're running on something smaller, you know, if you did training on 512 by 512 images maybe, then you might want to use these block swaps. And then we have our LoRa. So I'll show you in a second how we want to test these. But the other thing is so I don't know, to be honest, exactly why this is, but you don't want any of the single blocks on. So only use the double blocks when you're running a LoRa. Okay. Next we need the high bit embeds. So the text encoder, text encoders, make sure you select the KJ ones. We can use FP16 here just to save a little bit of VRAM. And then we're gonna have to go back here and do something else. So we want to use bits and bytes and also potentially sage attention. So we're going to go back into our environment here. This may not be necessary. If you're running out of VRAM when you try to do your installs, I would try to do this and see if it helps, especially installing bits and bytes is going to make a difference for you. Okay, so first thing we want to do is activate our virtual environment. Then I'm going to pip install bits and bytes. Okay, and then I want to also install Sage Attention. Sage Attention 2.0 does provide speed increases, but there's also Sage Attention 1, which is much easier to install, and you only get like 2% better performance by using Sage Attention 2. So I'm just going to use Sage Attention 1 for this example. Okay, and that installs in about 5 seconds versus Sage Attention 2 takes like 10 minutes to install. All right, so now that we have those installed, we need to restart our server. Okay, let's just go back here and make sure, yep, everything installed correctly. Okay, so we're gonna use bits and bytes quantization, and we're gonna use Sage Attention. And then we're going to use so this, I believe this only works on, the fast only works on 4090s. If you have a 3090, you might not be able to use this. And then we're going to use the FP8 just for testing, just for testing for now. And make sure you offload the device. Okay, and then I think that sets up everything on the left side of the Hunyuan Video sampler. And then we have our sample, we need to decode it, right? So we want the Hunyuan Video decoder. Let's load the Hunyuan Video VAE. And then the last thing is video combine at 24 frames per second. That's the output of Hunyuan Video, is 24 frames per second. And then change the format to MP4 for better quality. Okay, so I'm gonna drop the amount of steps down to 20 here, just so we can get faster generations. And then we are going to load our first video here. So looking at our Tensorboard, we are looking at probably either step 11 or 12, step 14 or step 18 as our best options. So I only saved every 2 epochs, so I don't have access to these odd numbers. So I'm going to start with 12 and see what my output is. So let's go back and see what our trigger word was. So in Diffusion-Pipe inputs. All right, so it's 5T1K for stick figure. So I'm just gonna say a 5T1K walking with a blank background, with a white background. And let's see if it works. Oh wait, which epoch did I say I was going to choose? Okay, I want epoch 12. So here's where we select our LoRA. Right now I'm on 10. I want 12. All right, so you can ignore these ones over here. We want these adapter models up top. So epoch 12. Let's see if this LoRA worked. I'm a little bit skeptical whether the stick figure is actually going to work, but we'll see how smart Hunyuan is. Okay, so this is actually better than I expected, right? It's not a black and white stick figure, but it is kind of stick figure-esque, and it is walking, right? It's not it didn't think that it was, you know, a person walking with a white background or an anime character walking with a white background. So I'm actually pretty happy with how that came out as an example. All right, so let's just test a couple of our other epochs and see what we get. I'm gonna fix the seed so that the seed is always the same and we can compare. All right, so let's fix the seed. And next, let's try, let's take a look at 14 and see how that one is. All right, so this, you can see some of this like graininess coming in here. This may mean that by this point the model is overtrained. So let's take a look at another one to see if the model is in fact overtrained or if this is just not a great epoch. All right, so let's take a look at 18. Okay, so 18 actually gets us even closer to the style that we're looking at. 18 actually looks really good. That's really impressive, actually, how versatile Hunyuan is. I mean, you can create realistic movie-looking scenes, and then you can create these like dumb little doodles that and even create a LoRa that mirrors off of those doodles. So let's just take a look at the last one. 20 here on our Tensorboard is also pretty low. We may get an even better result than we got with 18. Okay, so both 18 and 20 are pretty good. Maybe if I had trained it for another 2 hours or gotten another 10 to 20 more epochs, so 30 or 40 epochs, maybe I could get even closer to the style that I was drawing with. But I mean, for 4 hours of training, this is pretty impressive on probably something that wasn't in its original training data set. There probably weren't any dumb stick figure drawings in the original data set that Hunyuan was trained on. So pretty impressive inference for this model. So that is pretty much it. The last thing you have to do is whichever epoch you decide is the best, just go into the ComfyUI folder, go to models, LoRa's, go into your epochs folder, and just I think 18 or 20 was the best, so I would rename this to like stick 18, and then I would download that one, and then I would go to 20, and I would rename this one to stick 20, and then I would download that. And then now each time you load up a ComfyUI instance, you can drop your LoRa into this LoRa's folder and use it with this Hunyuan workflow. Another thing I recommend doing is creating a Hugging Face account and uploading your LoRa's into Hugging Face, and then using ARIA2C to download the Hugging Face LoRa, or downloading your LoRa's from Hugging Face. They just download way faster. It's maybe 20 seconds versus if you just try to upload it through the Jupyter Notebook interface, probably would take you 10-ish minutes. So that's it. That's a trained Hunyuan LoRa. If you have any questions, leave them in the comments. I know this is a lengthy process, but it really does. It pretty much encompasses like every skill you need for ComfyUI. So if you can do this, you're going to be pretty set for any new technology that comes down the line for ComfyUI. If you have questions or you run into issues, leave me a comment leave me a comment and I will try to answer them as fast as I can. If you have suggestions for new videos, or if you have advice for me for the channel, I would love to hear it. Leave a comment there, and please subscribe. Any extra subscribers I can get will go miles towards helping me put out more videos and better quality videos. So thank you for your support on getting started here, and look forward to more videos coming soon.